Hey everyone, welcome back. Let's look at another Leetcode daily challenge, and today's problem is largest combination with bitwise and greater than 0. So we'll not go through the problem statement today because I think it's more cumbersome and time consuming. Let me explain you the problem statement in my own words. So suppose we have an array of 5 elements A, B, C, D, E, and we have two possible subsets A, B, D, E and A, C, E, and the bitwise AND of all the elements in either of the subsets is greater than 0. So both of these satisfy the condition and we need to return the length of the largest possible subset. That is, the length of this subset is 4, the length of this subset is 3, so I'll return 4. 4 is my answer. Let's quickly look at the example test cases that we are given. So in the first example, we have a subset of length 4 whose bitwise AND is greater than 0. They have also shown that there is no other subset with length greater than 4 whose bitwise AND is greater than 0. Of course, there can be other subsets which have a length equal to the largest length. For example, here we have another subset which has length 4, but we don't care about that. We just worry about the length of the subset, which is identical. So we return 4. In the second example, we have two identical elements. So we pick both of them. Bitwise AND will be the element itself, and hence we return 2 in this case. Okay, now that we understand the problem statement, what is the brute force approach that we can come up with? I can think of a recursive solution where I generate all the possible subsets of a given array, calculate the bitwise AND, and if the bitwise AND is greater than 0, I store the result, keep doing it for all the subsets, and finally return the maximum length of the subset, wherein the bitwise AND is greater than 0. This will take exponential time complexity since it's a recursive approach. Even if I optimize it, even if I memoize it, it will be a quadratic solution. However, given the input size, a quadratic solution will also give a TLE. So we need to come up with even more efficient approach. So let's try to think bitwise. Okay, we all know what a bitwise AND operator is. Let's try to understand it in the current problem statement. When do we say that bitwise AND of two numbers is greater than 0? It means that there is at least one bit position wherein both the bits are set to 1 for either of the numbers. What do I mean by that? Let's try to look at some examples. So in case of 1 and 8, we have no bit positions wherein both the bits are set to 1. Hence we end up with 0. How about 4 and 5? We have exactly one bit position wherein both the bits are set to 1. And the bitwise AND in the result is greater than 0. So all we need to do is, for every bit position, we just need to check if it is set to 1 or not. If it is, it can be included in that subset. If it is not, it cannot be included in that subset. Let's try to take the first example and understand further. Okay, so I have taken the first example. These are the numbers and their binary representations. Let's try to go at each bit position and see which number can contribute to a subset wherein the bitwise AND of each element in that subset is greater than 0. We'll have a variable called maxLen which stores the length of the largest subset which satisfies our condition. So let's begin. Now we'll start with this position bit and see how many numbers do we have which have this position bit as 1 or this position bit set. So we have 17 and we have 71. So we have two such numbers which have this position bit set. So we'll store 2. We move on to the next position. Now how many numbers do we have which have this position bit set? We have 71, we have 62 and we have 14. These three positions. So our max length is now 3 because we found a better number, a larger number. Now we'll move on to the next position, which is this. And how many numbers do we have set? We have this, which is 71. We have this, which is 62, this 12 and 14. So we have 4 such numbers. So we'll update our max length to 4. Okay, moving on. How many numbers have this position bit set? We have 62, we have 12, we have 24, and we have 14. Again 4 does not exceed our max length, so we keep it that way. Moving on to the next position, how many numbers have this position bit set? We have 16, we have 17, we have 62, and we have 24. So we have 4 numbers which have this position bit set. Again, does not exceed our max length, we ignore it. Moving on to the next position, assuming all these empty spaces are zeros. How many numbers have this position bit set? Just 1. And we'll move on. Finally, we are here. How many numbers have this position bit set to 1? Only 1. So there you go. We have our answer as 4. We return 4. I hope the intuition and approach was clear enough. It's now time to code it up. We'll discuss the time and space complexity at the very end. Okay, so we'll start off by creating a variable called max length, in which we'll store the maximum length of the subset, in which bitwise AND of all the elements is greater than 0. Now, just as we did in the dry run, we'll loop over each bit position and we'll try to check how many numbers have that particular bit position set. How do we check if a particular bit position is set? We'll just create a mask. We'll also have a variable called current length that will store the length of the current subset, which is going to contribute to that particular bit position. Now we just have to loop through each number in the given array, and we just need to check if the current position that we are looking at is that position set in that number or not. If it is, then it goes into our current subset. So we'll increment our current length by 1. Finally, we'll update our max length with whatever subarray length that we have found for the current bit position. And we'll return the max length in the end. So let's try to submit. Okay, so we have a failing test case. Let's see what exactly went wrong. Okay, so we are taking AND of mask and 1. This should be X. We are taking the AND of mask and the number itself. Now this should pass. Let's see. Okay, our solution gets accepted. Great. So what would be the time and space complexity here? We are going through every bit position, that is 32 bits, which is constant, and we are looping through each number once for every bit position. So that is 32 into length of the array. 32 being a constant, we can just say this is a linear time solution, big O of n time. And what would be the space complexity? Space complexity will be big O of 1, constant space, because we are just using variables to store lengths. That's it. So time complexity is big O of n and space complexity is big O of 1. I hope you found this video useful. Don't forget to like and subscribe for more such videos. I'll see you guys in the very next one.